Hi, and welcome to the Hello, My Name is NativeScript webinar brought to you by Falafel Software. Let me start by introducing myself. My name is Keith Brunell. I'm a senior software engineer and trainer with Falafel Software. I've been developing software for over 15 years with my primary focus being on the web and mobile stacks. I'm a Microsoft and Telerik developer expert. I've spoken at developer conferences around the world, authored articles in MSDN magazine, and courses for Pluralsight as well. Before we jump into the fun stuff, we need to do the obligatory definition of this technology. So NativeScript is an open source framework for building truly native mobile apps with JavaScript. It allows you to use your existing web skills like TypeScript, Angular, and CSS to build apps with native UI and performance on both iOS and Android. And what this really gets you is two-way data binding between JavaScript objects and native components, CSS for native apps, which means the same styling constructs across both iOS and Android, as well as direct access to all the native platform APIs. At this point, you may be thinking to yourself, what type of crazy magic is this? Most importantly, it is not a web view. So the JavaScript or TypeScript code you write is not compiled in any way. What's going on is a JavaScript virtual machine, much like Chrome uses V8. Your JavaScript or TypeScript code is running in the VM, and then it's bridged to native code so you can invoke native APIs and build native user interfaces. I'm not going to walk you through getting NativeScript and its dependencies up and running because the NativeScript team has already provided excellent documentation for this, and it's available at the links as you can see on the screen. Once you have everything installed, we can write some code, which we'll start doing now. One of the paradigm shifts in development that I'm really enjoying is low ceremony tooling, and NativeScript embraces that by allowing you to do a lot via the command line. So here I have a command line open, and it's set to the directory Hello, My Name is NativeScript. Now I want to create a NativeScript application inside this directory. I start by typing TNS, which stands for Telerik NativeScript. All NativeScript commands are going to start with TNS. Then I type create, which means I want to create a project, and then I give it the name. And we're going to call it Hello NativeScript. So here I can hit enter, and NativeScript will chug through, and you can see Project Hello NativeScript was successfully created. So let's jump over to Finder and we can see that we have a Hello NativeScript directory inside of our Hello, My Name is NativeScript directory. So let's open this up in Sublime and take a closer look at it. So over in Sublime, I can expand the root, and we can see that we have 3 folders and 1 file under there. Let's start with looking at the package.json. You can see that this contains information on your packages and their dependencies. And we can see that we just have the NativeScript package and a dependency on the TNS core module. Now on to the folders. First folder is app. An app contains all of the developer resources. This is where you as a developer will be spending most of your time. The second is node modules, and it's just what it sounds like. It contains all of the node modules used by NativeScript, and out of the box, the only dependent node module that Telerik NativeScript has is TNS-core-modules. And lastly is the platforms folder. As we can see, the platforms folder is empty, and that's because we haven't told our app which platforms it will be running on. So let's do that now. And in order to do that, we can jump back over to the command line. And first we will get into our directory here. So I've just traversed down to my Hello NativeScript directory, and now I need to tell NativeScript which platforms my application should run on. And we do that, of course, by starting with TNS and then platform add. And currently our two options are iOS and Android. We're going to set it up for both. And we'll start with iOS. So you can see that it ran through and did its thing. And now if we go back over to Sublime, you can see that we have an iOS directory under platforms. And inside of there we have what you would expect to see in a native iOS application, including an Xcode project, the other configurations, and so forth. And the same thing works for Android. So TNS platform add Android. Again, it'll go through. It takes a little more to install the Android pieces. There we go. And now when we come over, we have our Android folder. And again, everything you'd expect to see in a native Android application, including your Android manifest, your Java references, your assets, etc. Out of the box, NativeScript includes, I'd say, a starter template for every application that it creates. So at this point, we can run this and actually see an application. And we run it from the command line. And I'll start with iOS. TNS run is the run command. Then we give it the platform, so in this case iOS. And because I don't have a device currently connected to my Mac, I'm going to run it in the emulator. And I tell it that by giving it the emulator switch. So TNS run iOS emulator. Hit enter. And it's going to run through and spin up the simulator. I'm not sure why the command line switch is called emulator, because it's actually a simulator that's running on iOS, but it looks like it popped open on a different window, so we'll drag it over. And you can see that we now have the default out-of-the-box application, which is basically one screen with a tap on it, and you can tap that down, and if you tap it all the way down to 30, it gives you a big You've Won award. All right. So since that's so big, I'm going to drag that out of the way. And now we can do the same thing for Android. I'm going to open a new tab so I can get to there, and then I will traverse to that directory. All right, so now I'm in that directory. And now I could spin this up with TNS run Android emulator. But since we have a short time span in our webinar here, and if you've ever used the native Android emulator, you know it takes quite a while to spin up. I'm not going to do that. I'm going to take advantage of a tool called Genie Motion. So this is Genie Motion. It's free for personal use. And I already have it runs off of an AVD. So I already have an AVD imported here. And I'm going to start up this AVD. And it actually runs as a virtual device. So you'll see that when I spin up the app against this virtual device in NativeScript, that I don't actually include the emulator switch, because according to NativeScript, it sees this as an actual device that I have plugged into my machine, or an actual hardware Android device. So we have that spun up. Now we can go back to our command line, and instead of TNS run Android emulator, we can just do TNS run Android. Get that out of the way. And it'll go through its thing. Basically, it's deploying it to the virtual machine. right, you can see that the build succeeded. And hopefully it'll pop up on our emulator here. Now this is actually an emulator because it's emulating actual hardware, and you can see here it is. It pops up on the screen, and I know you're all dying to see what happens when I click this that many times. So I will click through it very quickly, and hooray! I've unlocked the NativeScript clicker achievement. So there you've seen me spin up a basic Telerik NativeScript app and set the platforms for both iOS and Android, and then run it and display them on the screen. So now let's look at some code. So I'm going to get some of these guys out of the way. All right, I'm going to close out the platforms tab because right now we want to focus on the code. And as I stated earlier, the code is under the app directory. So let's break down what's all in here. First folder is app resources. And app resources contains resources that can either be general, used for both platforms, or platform specific. Here you can see images per platform, which is, if you've ever done native applications, you know that you typically have a specific set of images for Android and a specific set for iOS because they're rendered differently. So here you can see we have Android resources and we have iOS resources. You know, all the different icon sizes for both iOS and Android. Next we have app.css. And this is where you would store global styling for your application. Remember from the start, all styling in NativeScript is done through CSS. It is a subset of CSS, but from what I've come across and from what I've heard from other developers, that 95% or more of what you use on a daily basis as a web developer is available through this subset of CSS. So this should look very familiar if you've done web development. Next we have app.js. So if you've done any web development using any of the new modern JavaScript frameworks, the concept of an app.js should be fairly familiar. And this is where we configure our application and basically start it up. All right, so I'm going to close these guys. And the next three files comprise the one view of our application. So if we recall, we pull up our simulator back up. You can see our application contains one view. All right. So the first file is mainpage.js. And this is the JavaScript code behind for our main page. Don't let the word code behind throw you off if you've done any ASP.NET, old school, not classic, but in between new and classic. The term code behind kind of has a negative context. That's not what this is. Basically, it's a set of JavaScript code that is associated with the view. So there's no double clicking on a button and have some magic button click handler created. This is you coding the code behind. Okay. The next page we have is mainpage.xml. Again, don't let XML turn you off. This is basically HTML if you think about it. It's attributes and values. All right, so here you can see we have our page. We have a navigating to, which is a way of declaring events. So when this page is navigated to, the on navigating to method is fired. We'll take a look at that in a second. And there are sets of layouts that are predefined, which you can check out on the NativeScript site. You can nest them. So here we have a stack layout and then some labels and buttons. All right, all of this should look pretty straightforward. The text is being set via text equals to a string. You can see we're setting a CSS class here, text wrap, pretty common HTML and CSS properties. The final page here that goes, or the final file that goes along with our view, is called main view model. MVVM is the recommended pattern when building NativeScript apps. And like the name says, this is the view model that goes along with our page. So as in any MVVM framework, this is going to do the bulk of the work. It's going to tie the view, which is our XML file, to our JavaScript. It's going to be the correlation between the two. All right. So here we have a function called getMessage, which looks like it loops through and gets the message depending on where our tap count is. And then we have a constructor called createViewModel, which we will talk about in a little bit. All right, so how do those three pages come together when our app is ran? To start off with, mainpage.xml and mainpage.js get associated using convention versus configuration. So the NativeScript framework knows that a file in the same location in the directory structure that has the same name as the view, so here we have our view is called main-page.xml, and then we have a JavaScript file called main-page.js. So it knows that because it's named the same and has a .js extension, that it is the code behind for that view. The view model gets brought into the mix via some code in the mainpage.js. So here we're using require, and we're requiring, so basically we're pulling in that view model file, so the view model.js file, which basically gives us access to that file. And then we're setting a variable equal the createViewModel function, which is, if we look over at that, it's basically returns the view model. So think of that as the constructor. So we're not actually executing the function here, we're just setting this createViewModel variable equal to that function. And then down below, we're setting the page binding context to the execution of that function. So basically to the view model. So we've already walked through creating a Hello World NativeScript application. Now let's take a look at a little more complex of one. So I've created the base app and I've modified the structure to align with the best practices. We still have the same top-level folders, app, node modules, and platforms. But I've added a couple of folders under app that simplify things when dealing with a more complex application. The first is a shared directory, and this will contain any files that will be shared across all views. Currently there's one configuration file called config.js, which contains an API URL and an API key that we'll take a look at later. The next folder is views, and that's going to be a container to hold all of our views. The initial view of this application is called login. This view currently has a vertical stack layout with the standard login controls. You can see I have all the options available natively to configure a text or input field, things like keyboard type and autocorrect and auto capitalization. Now if we spin this up, I'm going to spin this up using the live sync functionality. So that's going to allow me to modify my changes or modify my application and have them live sync to my emulators instead of having to spin up the emulators each time. And the syntax for that is TNS live sync, then the platform, and then emulator, and then -- watch. That means it'll be watching for changes and it'll sync accordingly. So we'll start up the iOS emulator, and we'll do the same with the Android. Again, TNS live sync Android -- watch. And those should spin up, and we will see this. So basically we have a very unattractive login form for our application. So now is a good time to talk about styling. NativeScript has a hierarchical way it applies CSS style sheets, just like the web does, most generic to most specific. So app.css in the root of our app folder is the most generic. So I already have some settings in here that I'm just going to uncomment. And if we save this, should be able to come over here and see that we did indeed live sync. If we did, so this looks like our iOS live sync may not be working. So let's make a change again over in app.css, make that green and save it. You can see it is working for Android, but it doesn't appear to be working for iOS. That's a bug I've come across quite a few times, so we won't dwell on that right now. But since that green is very unattractive, let's go back and get rid of that. So you can see by adding those global style sheets, or adding those elements to our global style sheet, our Android app now looks presentable, right? Our iOS app, not so much. So we don't want to impact our Android app by any styles we add to fix our iOS app, because then things will just get out of whack. So at this point, we need to create an iOS specific style sheet. And we can do that pretty easily. So if I create a new file in the root of the app directory, it needs to be there. That's where NativeScript is looking for it. And I name it platform.ios.css. Again, that's the naming convention that is required. Platform. The name of the platform.css. And I save that. And I'm just going to copy over some CSS I have in another file. Paste it over. So here I'm applying some CSS to the button and the text field. And we can save that. And there's one more thing we need to do before those styles can be applied. And that is to reference or import that's platform specific style sheet into our core app style sheet. And we do that using the import statement. So I'm saying import url/platform.css. All right, so now we can save that. And we can see that nothing happened in our Android emulator, and that's good because we didn't create anything Android specific. But now we'll have to go in and we'll have to restart our iOS emulator because it doesn't seem to be live syncing. So tns run iOS emulator. And now when this pulls up, we should have a login page that is a little better looking. There we go. So that looks a little better style-wise. So I was able to create an iOS specific style sheet by placing a platform.ios.css file in the root of my app directory. Again, that's convention over configuration. I didn't have to configure anything to tell NativeScript where that file was. It knows to look for a file with that naming convention, and if it finds it, there it is. So at this point, you may be wondering, like I was, how the heck does that work? Because there isn't a platform.css. So here we're trying to pull in a platform.css file. And here's what's going on. When you TNS run or TNS live sync, the NativeScript CLI makes your code or takes your code from your app folder and places it in the native projects located in the platforms directory. And while doing this, NativeScript selects anything that is .android.star and or .ios.star and places it in the according folder and removes the platform-specific denotation. So platform.ios.css in the root of /app becomes platform.css in the iOS build. And we can see that if we take a look at platforms.ios .popular TV app /app, we can see platform.css, and that contains the same CSS that our platform.ios.css contained. And there's another, wow. There's yet another level that we can set CSS at, and that's at the view level. So if I wanted some CSS specific to my view, I can go in my view, add a new file. Oh, it's already there. So we'll just take advantage of that. Here we have login.css. And if I change that to blue, you can see that our Android app updated accordingly because that's view specific. It's not iOS or Android specific, it's view specific. So by changing that, it was specific to this view. But if I had another page that had text fields on it, they wouldn't be impacted by this because this is specific to login.css. Of course, there is the final overrider of all, and that is inline styling. But I'm not going to touch on that because I have a very specific viewpoint on inline styling, and it may not agree with yours. We won't wire up the entire login page, but we do need to be able to navigate to the next page at least. So we need to wire up the sign-in button. So as you can see here, the tap of our button is assigned to a function called sign-in. So over in login.js, I'm going to delete that. Then I'm going to bring in a function called sign-in. All right. So this is basically putting a function on the global scope called sign-in, and it's using the frame module to navigate to a view called list/list. So that's going to be a view in the list folder called list.xml. And there's one final thing I need to do before that navigation will work. And that is to pull in the frame module. All right. So I'm using require to pull in the frame module, and that is part of the NativeScript core. So now if we run this, it's still not going to work because we don't have our list page in place. So let's just quickly throw in a list page. So I'm going to create a new folder. Oh, there it is, new folder. We're going to call that list. And then we'll create a couple new files. We'll create the view, so list.xml. create the JavaScript list.js. And then for this guy, we're going to use a view model. So one more new file, and we'll call that list-view-model.js. All right, so let's close some of these guys. So we're not getting confused. Then I'm just going to start populating some of this stuff here and explain as I go. Okay, so list.xml is our view, and this is going to contain a grid layout. It's going to be bound, or it's going to be a list view that's bound to a collection on our view model called popular shows. And then for each item in the list view, we have a list view item template, and all that's going to do is display the name of the show. All right, and then we're going to jump over to our view model. We'll place some code in there. All right, so view models in NativeScript are instances of .observable. So here we're requiring the data/observable, which is a core NativeScript library. And then I have an encapsulating function called listViewModel, which is the name of my view model. I'm declaring a new view model and setting it equal to a new instance of observable. And then I'm just creating a property on my view model called shows, which at this time is just a hard-coded array of shows. And then the result of that is return the view model, and then I stick the view model via a module.exports basically on the scope. Now over in our list.js, we'll copy in some code. Basically this is pulling in the list view model and declaring a new instance of it. And then on exports.loaded, so basically the loaded function of our view, we are binding the binding context to the new view model. So let's make sure we have, yep. So on our page, we have a loaded equals loaded. So basically when the page gets loaded, it's going to call this loaded function. All right, so let's save that. Come back over to our Android app, which should be in a good place. And we got to the next page, but it looks like we have an error. So let's figure out what that error is. All right, so we have viewModel.shows here. Oh, there we go. Name mismatch there in my code. This should just be shows. So now if I save this, there we go. Now you see that we have our shows displayed. So that time we used the MVVM pattern. We exposed the view model and bound that to our list. Now that we have the bones in place, we can modify this code to pull from an actual web endpoint. So to start, I'm going to pull over a few additional things in my view model. So I'm pulling in the fetch module, which is going to allow me to make my HTTP call. An observable array, because I'm going to store my shows that I receive from my API in an observable array. And then I'm pulling in that config file that I created earlier that contained the API URL and the API key. All right, we'll start by pulling in some modules. The first is the fetch module, and that's going to allow me to make an HTTP request. Then I'm going to bring in the observable array, because my collection of shows is going to be an observable array, so it can be bound as part of my view model. And then we're bringing in the configuration file that we talked about earlier. All right, and then we bring in one more piece of code here. That's going to replace this view model.shows declaration. Let's get that lined up so it doesn't look out of place. All right, so what we're doing here is we're declared viewModels.show. It looks like I have double there. ViewModel.shows as a new observable array. And then we're declaring a function called viewModel.loadShows. And that's going to configure a URL that's going to go to an endpoint that will return popular TV shows. And then we're going to tell it to fetch. And then basically we have a promise chain. The first promise will convert that to JSON. And then the second will basically pop everything off our existing array and push everything back on. So at the end, we should have a fresh list of shows. So at this point, we can save this, and there's one more change we need to make. Our view model now has a load shows function that we're going to have to call, and we'll do that right after our view model is bound to our object context. So we will call view model .load shows here. And we'll come back over here, click sign in, and you can see now that we have a much larger list of shows, and these were actually returned from an API call to the api.themoviedb.org. So now we have a little more robust application which makes HTTP calls and actually binds to data and does things that we're more apt to do on a day-to-day basis for the applications that we build. Wow, that was quite a whirlwind. I hope everybody enjoyed. Hello, my name is NativeScript, and stay tuned to the Falafel blog for more information on NativeScript, including using TypeScript and Angular 2 with NativeScript to build awesome mobile applications. So thanks again. If you need to reach out to us, the information is on the screen. Hope you guys enjoyed. Have a good day, and I'll be ready for questions.